Welcome to this latest webinar from the Delta EE Local Energy System Service. Today we will be talking about resilience, which is a rather topical subject given the current situation across the globe. But before we get into that, I'd like to give you a brief introduction to Delta EE and our research service. Delta EE is a research and consultancy company specialized in the energy transition. We offer bespoke consultancy projects as well as subscription to annual research packages on 12 different topics at the core of the new energy sector. The Local Energy System Research Service is one of them and looks at challenges and opportunities created by the growth of energy communities, microgrids, and local energy markets. I'm joined today by Jeremy and Rita, who will be sharing the presentation and are available to answer your questions. We have planned around 30 minutes of presentation, and for the question, please feel free to contact us. The email will be shown at the end of the presentation. For today's webinar, we're going to talk about what is resilience and how microgrids and energy communities can provide it. But first, let's have a look at what our network thinks about the potential of local energy system to provide resilience. Last week, we shared this poll on LinkedIn. We asked, in 5 years' time, which type of local energy system are the most likely to provide resilient services to DSOs? And the results was that 21% of respondents said microgrids, while 30% think that energy communities and collective self-consumption scheme will serve the scope, and 18% voted for peer-to-peer trading schemes and local energy market. Let's see if after our webinar, someone will change his or her mind. So let's start now. What is resilience? The term resilience means the ability to prepare for and adapt to changing conditions and withstand and recover rapidly from disruption, while reliability of a system refers to the performance of the system under normal operating conditions. We decided to talk about this topic because resilience is becoming a major concern as the energy system becomes more complex with increasing amount of intermittent generation. And we also decided to talk about the term resilience, referring to societal and economic resilience. In this webinar, we're going to explore how local energy system can provide different types of resilience, specifically how microgrids provide technical resilience when the grid fails and and during period of stress. On the other hand, energy communities can provide societal resilience by creating economic benefit and support the local community where they are located. And now I'm happy to pass it on to Jeremy, which is going to talk about microgrids and the energy system resilience. On to you, Jeremy.
Thanks for that introduction, Oda. So we just heard that resilience is different from different types of local energy systems. As Oda says, Rita will be speaking in a minute about societal resilience and how energy communities can provide that, supporting local communities, providing employment opportunities, generally keeping value within the community. But here I'm going to focus on energy system resilience, keeping the lights on, even during exceptional circumstances. And of course, it is a precursor to that a resilient system also needs to keep the lights on under normal circumstances. That is, it must also be a reliable system. Now, energy systems have always been subject to extreme weather events, floods, earthquakes, other natural disasters. And I'll come on to that in a minute. But what we want to talk about here is the rapid developments taking place today in the electricity system and how they're raising our awareness of additional challenges. So our society is becoming increasingly dependent on electricity to provide mobility, heating, and more recently working from home. That's in addition, of course, to the services provided by electricity, such as lighting, which we now just take for granted. At the same time, the energy system which provides this electricity is becoming increasingly dependent on renewable generation, which brings its own set of challenges. Not only is that generation intermittent and generally non-dispatchable, but it also lacks system inertia to maintain stability. Now, that doesn't mean we should abandon electrification as a means of decarbonisation, nor that we should abandon intermittent renewables as a source of low-carbon electricity, but we do need to understand the implications of such policies and ensure the systems are able to provide the levels of resilience required to make them a viable alternative to our current system. So resilience is clearly growing in importance, but is it worth investing more in resilient networks, and on what economic basis we make those kind of investment decisions? And that's what we're going to start looking at here. We often hear staggeringly high numbers quoted for losses resulting from natural disasters, such as the $2 billion attributable to one single public safety preventative shutdown event in California in 2019. And the numbers shown here are certainly quite dramatic, but they pale into insignificance when compared to the recovery costs caused by the failure of the Fukushima nuclear plant, variously estimated at anywhere between 500 billion to more than €1 trillion. Remember that that was the result of a failure of a power supply to control the cooling pumps on the power plant. But whilst it's relatively easy to quantify losses after the event, it's less straightforward to justify resilience investments in anticipation of unknown events. And investment decisions need an economic rationale, which requires 3 stages shown here. The first step, of course, is to agree some means of quantifying resilience, and performance-based metrics such as the duration of outages, the number of customers affected, the amount of energy not delivered, are all used to incentivize network investments. So let's consider valuing resilience from the customer perspective. And it's not a simple question, because different customers will attribute a different value to resilience, whether that be industry, critical infrastructure, or households. Industrial customers tend to place a significantly higher value on resilience than households. After all, there's a direct and immediate cost attributable to loss of production, whilst households generally suffer only perceived loss, which is harder to define. However, even here, recent studies have shown an increasing value attributed by households, a trend which is likely to continue in a post-pandemic world, with increased home working ever more dependent on a resilient electricity supply. For industrial and commercial sectors, the value of resilience, as shown here, ranges from a few euros per kilowatt hour to more than 250 euros per kilowatt hour. The values shown here are for peak values, although in some cases the value can be relatively low or sometimes even zero, depending on the criticality of the process affected. And that's hardly surprising. Some applications, such as food processing or storage, in the event of power outage, the entire stock value could be destroyed. In others, such as plastics manufacture, not only is the batch lost, but it may be necessary to disassemble the production line to remove solidified residues. It's also interesting to note the wide variation between regions, with the USA and New Zealand attributing extremely high values to resilience. We haven't shown the exact numbers here, although these are available in the full report, but it should be noted that the industrial values shown in the graph on the left are actually around 10 times those of the residential customers shown on the right. So clearly that resilience has a significant value in terms of lost income for business, loss of service, loss of life. But for a network operator with responsibility for maintaining supply and with financial incentives to underpin this, is it worth investment in physical assets? Is some other technology solution cheaper, quicker, more effective, or should they just ignore it and suffer the economic and reputational consequences? The slide here shows compensation levels which must be paid by network operators in Finland based on the proportion of the annual grid fees and the duration of the outage. And similar schemes are applied in other markets, along with fines and rewards in some cases. So what are the options open to network operators and others responsible for providing a resilient supply? Historically, a more resilient system has been a more expensive one, with overspecified components, redundant and backup systems, commonly referred to as copper in the ground. Increasingly, innovators are turning to better optimized approaches, and in many cases, non-wires alternatives are being actively encouraged by regulators. And one such technology, which amongst its many benefits includes inherent levels of resilience, is that of microgrids. So what is a microgrid? The definition shown here is that microgrids are electricity distribution system containing loads and distributed energy resources that can be operated in a controlled, coordinated way, either while connected to the main power network or while it's islanded. This means that microgrids inherently provide an additional level of resilience to the main grid. In normal grid parallel operation, microgrids can provide flexibility and other services to the grid, improving stability and resilience. And in the event of an outage on the grid, the microgrid is able to disconnect and operate in island mode, providing a continued resilient energy supply to its customers. When the grid is re-energized, the microgrid is then able to resynchronize and reconnect without any loss of service to its customers or impact on the grid. There's a significant difference between reconnecting a microgrid and reconnecting a dead circuit. In the case of the microgrid, at the point of reconnection, there is no net power flow into or out of the microgrid. On the other hand, a dead circuit will have significant loads which will need to be met instantly on reconnection. This makes the process of re-energizing the grid after an outage a complex and time-consuming task. Another benefit of the microgrid in this respect is that of distributed energy generation connected within its bounds. In most European countries, distributed connected generation is required to disconnect from the grid in the event of either a grid failure or even if the supply deviates outside statutory voltage or frequency limits. In the case of the UK grid failure in August 2019, this was the principal cause of the cascade failure of the distributed generation following the loss of 2 larger power plants. And here again, the microgrid can provide resilience in that if the anomaly caused the microgrid to trip off the main grid, it would take with it not only the loss of generation, but also the equivalent load, resulting again in no net impact on the wider grid and avoiding a cascade failure. Beyond that, recent trials in the UK are also demonstrating how microgrids could be used even to re-energize the entire grid following an outage, using several microgrids to provide stable generation sources connected to the distribution grid, rather than relying on large-scale centralized plants connected to the transmission grid. And so, not only can a microgrid provide a resilient energy supply to its own customers, it can also support the wider energy system. So earlier I mentioned the monetized value attributable to resilience. In some cases, these values are not in themselves sufficient to justify conventional grid investments. And indeed, the cost of upgrading rural feeders is often prohibitive, and a DSO may resort to installing backup generators at strategic locations on the network in order to reinstate supply whilst the inevitable overhead lines are repaired. This is a particular crude, expensive and environmentally unfriendly solution, and it's being increasingly replaced with more sophisticated non-wires alternatives, including microgrids. And the use of microgrids or other non-wires alternatives may not only be cheaper than conventional solutions based on upgrading grid assets, they also provide additional services and consequent revenue streams. So that if the value of resilience represents just one value of a stack of values, including lower generation costs using local renewable resources and provision of flexibility services, then even a marginal business case can become rather attractive. The challenge here is that whilst the incumbent DSO may be incentivized to invest simply as a non-wires alternative to comply with their license conditions, it's very difficult for them to capture these additional values attributable to microgrid operators. So an optimized system is incorporating microgrids is likely to stimulate innovative business models, which may include partnerships between, for example, the network operators, energy suppliers, energy communities, and other solutions providers. However, given the many values provided by microgrids, they're becoming an increasingly attractive solution. Indeed, previous reports from the Delta Research Service on business models have shown how microgrids are already economically competitive in many applications. So I now briefly outline a few examples of how and where microgrids are providing resilience, and in some cases these range of additional services. There are numerous examples of microgrids providing resilience across the globe. In the case of the Sendai University Hospital in Japan, a microgrid managed to maintain electricity supply to critical services throughout the tsunami event in 2011 and incrementally restored other less critical services shortly afterwards as additional generation was brought online. This microgrid was primarily designed to exploit local resources, solar PV and so on, and reduce operating costs and emissions. However, its secondary role as provider of resilience adds significant value to its operation. Another Japanese example, the Fujisawa Smart Sustainable Town, built on this experience to develop a community microgrid in which individual households' generation assets, including solar PV and fuel cells, are used both to provide an uninterruptible power supply within each home, but also used to support the overall local energy system, maintaining street lighting and emergency community services, for example. However, even where resilience alone is the driver, it's often the case that non-wires alternatives are a more cost-effective means of providing resilience. In some countries, remote communities have always been served by microgrids. It would just be too expensive to build the long feeders from the national grid. But in Australia, there's an interesting situation where even where there is a conventional grid already in existence, in some cases it's being abandoned in favour of microgrids due to the extremely high maintenance costs for the conventional solution. Now, even in Europe, there are initiatives to implement non-wires alternatives as an optimum investment strategy. And one such example is the proposed Resilience as a Service project on the west coast of Scotland, where utility-scale battery storage is being used to provide resilience to a remote community rather than resorting to diesel backup generation. However, we should say that in Europe, the focus of energy system initiatives tends to be driven by the zero carbon agenda and desire to improve system efficiency. It'll be interesting to see if this priority can be maintained while simultaneously providing increased resilience from the same microgrid investments. There are estimated to be around 5,000 microgrids worldwide. Around 10% of those are located in Europe. And as noted earlier, by definition, all of these provide some degree of resilience in that they're able to support their internal loads in the event of grid failure, for example. They can go further and provide resilience to the wider energy system or provide additional services and value streams. And even in Europe, we're starting to see increasing numbers of microgrids whose purpose is to provide resilience. And indeed, both microgrids and other non-wire solutions providing resilience are being encouraged by regulators in several European states. It can be argued that whilst development of microgrids with the sole purpose of providing system resilience is of value, it would be much better to use those microgrids to provide other equally valuable services at the same time for little or no extra cost. So with that, I'll hand over to Rita, who will tell us about the other types of resilience, economic and societal, which can be provided by local energy systems.
Thanks, Jeremy. Sorry for that. I have the control now. So energy communities are deeply linked with the topic of resilience, and not only talking about technical resilience, but as well about societal resilience. So by societal resilience, I mean that energy communities have the potential and are already proving to bring many benefits locally, whether it is bringing economic or societal resilience. So I would like to bring here a nuance around the fact that energy community can't provide technical resilience. I would say that energy community also have the potential to bring technical resilience, and this in two ways. So first, they could have the opportunity to improve their local energy systems to the point that it becomes technically a microgrid. And secondly, they could also utilize the big assets from the community through aggregator to provide resilience. So when I talk about energy community, I'm talking here about the definition of the European Commission. And I mentioned the two directives from the Renewable Energy Prosumer in the Clean Energy Package. So the first definition is what we call the citizen energy communities that are included in the Electricity Market Directive. And then the second definition, which is the renewable energy communities within the Renewable Energy Directive. So as most of you know already, those two directives give rights and define the term of energy communities as being legal entities. And every European member states must transpose those directives into national laws. And we are right at the moment of in that process because by June 2021, all European states must have translated those two directives. For instance, just this week, France have announced their new framework, regulatory framework. So why supporting energy communities to provide societal and economic benefits, and what are they? First, when we speak about economic benefits, we can speak about the revenues from local investment. I will illustrate this in the next slide. But then secondly, we speak about savings on the energy bill, which can potentially become significant. If we take the example of a municipality participating into an energy community and installing solar panel on their municipality buildings, such as the school, a warehouse, we've seen cases also on the church roof, the savings on the bill for the community can be significant. There's also the creation of high value local employment, services and skills within the community, and the possibility for capital investment and co-ownership, which is also really interesting, not only for the capital being brought by individual into the project, but as well for the fact that it represents more interesting investment than a basic saving account that in general tend to yield around 0.5%, so barely the inflation. In this case, we are seeing interest rates between 4 to 8%. So, community investment in renewable energy, as I was saying, can offer a greater return on investment compared to private investment. So this is the example in France, where when we see a private project, the revenue locally are the rents, for example, a field or a roof where the assets are installed, and then the local taxes. But there's a certain value that is not accessed by the community. When we look at a project, when the community access the invested by the community, the revenue can be multiplied by 2 or 3, depending on the contribution, with revenue from local investments, and then the local employment and services, so local job creation. So that is quite significant for the community. Now, when we look at the societal benefits, I have tried to summarize, but the list could be much longer. What societal benefits does it bring? Well, it brings a greater end user understanding and engagement into the renewable energy, and then we see programs around energy efficiencies, around trying to tackle energy poverty, energy securities, depending on the project. It's also improving the social fabrics and bringing people together, which is in some cases critical, where there's a social problem, for example, or in rural areas. It improve and accelerate the participation to the energy transition, and it brings more social and environmental fairness. So those are all really good points to consider. So now the question is how to support energy communities to provide societal and economic resilience. Well, first, it's important to know the internal factors that are impacting the financial economics of energy communities. I will describe those in the next slides because they are, yes. And then second, they are tools or frameworks that can support the social cohesion of a project. And I will present for this an energy justice framework and its potential to ensure a robust foundations for a business model and better communication and knowledge diffusion. So we find social resilience at the heart of the internal factors impacting the profitability of energy communities. So first, to cleanse the landscape, we have external factors. So depending on where we are and in which European market we are, there's the policy and regulation Is there regulation allowing energy communities? What are the risks, like heavy bureaucracy, for example? And then we look at the market conditions, such as the demand, the appetence of the customer, the electricity prices influence greatly the demand. There's the available value streams, such as the possibilities of providing flexibility. There's the state of competition, and there's innovation. And now the bit that interests us, the internal factor. And first is the governance dynamics with partnership and project creation. We find that top-bottom projects do not show as much as engagement as a bottom-up project, where the prosumers or customers show better engagement into the project and then therefore better success. And why? And that lies into the customer's motivation understanding. We realize that when the project is local, it brings a social norm, and then it brings a better community identity. And we see that most of participants also have that wanting of participating and accelerating the energy transition. And there's that as a motivation, that possibility for capital investment, because we've seen that this represents interesting economic outcome as well. And then that possibility of having a democratic governance, which brings trust and confidence. And for this, we need a good way of facilitating the knowledge acquisition and diffusion. And this within the energy communities, between partners of the energy communities and the energy communities, and with the wider economic system, energy system. And at last, I want to talk about innovation, which comes back to that bottom-up governance type, where when it's well done, we can see in some cases grassroots innovation, and that can be fed back into the wider energy system and help other energy communities to become more innovative and bring more economical and societal value. So to achieve partnership with energy communities, incumbents and energy community in general need to foster trust and social resilience. And a way to do this is applying an energy framework that respects 3 key principles. So some of the most frequent questions from energy companies regarding the potential of energy communities as a business grows are around business models, and especially their replicability, scalability, and economic viability. So the further we investigate the topic, the more we come to the realization that if large organizations want to be successful in building business models, enabling the development of energy communities, the principle of energy justice and fuel poverty need to be built in. So what is energy justice? That is quite simple. It's a concept that aims to provide all individuals with safe, affordable, and sustainable energy. So within this concept, decisions, for example, on infrastructure setting, subsidies, pricing, consumption indicator within the context of national and local pressure need to address the problem of unequal distribution of benefits and responsibilities. So that leads to the first tenet of energy justice, which is the distributional justice. And that represents a call for even distribution on benefit and responsibility across all members. Then second, we have the procedural justice, which is a call for equitable procedures where all members should be able to participate in decision-making without being discriminated, and including full information disclosure. And then we have the recognition justice that states that individuals must be fairly represented to avoid any form of domination, including divergent perspectives rooted in social and cultural differences. And this enables the recognition of the needs of particular groups and increase the success of some projects, for example, tackling energy poverty. So, in summary, applying the 3 tenets of energy justice to energy communities can provide an interesting tool to ensure the success of longer-term partnerships, better uptake of changes and innovation flow to travel bottom-up as well as back top to bottom. So, the future of local energy system combines technical resilience, social resilience, to enhance the value brought by and to energy communities to stakeholders. So in terms of resilience, optimization is key, and it will be done in layers. So first, within the home at the appliance level. Second, optimization within the local energy systems. And then we see flexibility service at the distribution level to, for example, relieve local constraints. So we speak about the technical resilience here, and then the flexibility service at the transmission level for ancillary services. So looking into the future, we see 3 potential scenarios unfolding. Like a first scenario could be, for example, that incumbents or other energy companies do not find a way to really develop quality partnership with energy communities, and that may lead to see their value eroding by losing market share. And then on the other hand, we would see energy communities flourishing and participating on European markets with networks of learning and innovation. I think it's unlikely because we're already seeing my second guessing scenario, which would be that energy companies along the value chain create advanced tools to create and facilitate service for local energy systems, while other focuses on standalone consumer. And then energy community will develop some of them will use the support of innovative products offered by other energy stakeholders. And then the market slowly evolves toward an increased democratization of energy system. Another scenario is that energy companies manage a transformation of their business model, foster a fully decentralized system in partnership with energy communities, and other type of local energy system provide all the services needed for any group composed of individuals, SMEs, municipality, to create network of local energy system, microgrids to the larger energy system, with the possibilities of participating to energy market through easy to access platform. And here, innovation and learnings operate bottom up, so it travels really well. But in the short term, in the next 5 years, this is quite unlikely to happen, and I think we need to wait a little bit more for this to happen. I think this is it for me, so thank you for your attention, and I will let Lodo closing. I think, Lodo, you're on mute.
True, sorry. Thank you, Jeremy and Rita, for this very informative and interesting presentation. And thank you for the attendees to join us today in this webinar. Please, if you have questions, contact us at our email available on this slide. And if you want to know how to access our research, please contact Rita, in charge of our business development. Thank you very much, and see you soon.
Thank you.